All right, continuing on with our series here on automating the crisp DM process. In our first few videos, we've gone through automatically performing the exploratory data analysis process, including all of the univariate and bivariate visualizations and metrics. Now we're going to move on to some automated data cleaning, and it's this kind of a conundrum here because data cleaning is the least automatable portion of this whole process. Every data set has unique issues that depend on the domain area or domain expertise or the theories of the people who understand the data and what's going on with it. And it's not something we can fully automate. However, that doesn't mean we can't do some things to make the data preparation process easier and quicker, or at least to automate or support the ability to make decisions quicker on how to clean everything. So I'm going to continue with these 4 data sets. Actually, I think I added one here. I'll have links to them into the descriptions. Each of them are available on Kaggle. So I've used 3 of these in the prior videos. I think the insurance and the NBA data set and the airline, and I've added in another here with Airbnb because it has some other issues that I want to be able to include in this next example. So go ahead and copy my code, bring in these data sets, get Google Drive mounted if that's what you're using. And while you're doing that, I'll briefly explain everything we're going to go through. So I'm going to start with the most basic data wrangling steps, handling empty columns or columns where every value is unique or where almost all the values are unique, like primary key columns. Maybe you pulled something from a database and there was a primary key, or a row index is still got saved somewhere. Anyway, columns with one value. This is really simple, easy stuff. We'll write some functions to automate that. We're going to learn how to automatically parse out dates into month. We're just going to turn it into month, weekday, day of the week, day of the month, and month of the year, and all that stuff. Nothing too fancy there, but I'm going to give you ideas on how you can expand these to make them much better. We're going to go through an example of automatically binning low count group values. This is very useful. So this is kind of in between where we have enough standardized values that they're not all unique, or at least mostly unique. However, we might have some values that don't have enough rows to represent everything. So to adequately model later on or come up with reliable analyses for. So we'll make some functions to auto bin categorical features. Then we're going to get into some examples with outliers. And here we can make some pretty killer functions that give us a lot of options that really automate that. This is a nice one for automation here. Next, we'll go into automating issues with skewness. Now, this one's a little controversial. Some people, a lot of data scientists don't care a whole lot about skewness anymore since we have such good algorithms that can handle it. However, I found that these linear models still 1 out of 10 times or so will end up being the best algorithm we have when it comes time when we get to the modeling phase, and they depend on some of those basic assumptions we learned back in Stats 101, like normal Gaussian distributions. So we'll make a function to automatically adjust those. And then finally, we'll handle all 3 types of missing data, at least as much as we can. So again, none of this is going to be as automated as our data preparation, our data understanding or EDA phase was, but we're going to make some progress. All right, let's dive in and go ahead and pull in these data sets, explore them if you haven't already. Take a moment to make sure you understand what's in there. And let's begin with some basic data wrangling here. So I'm going to make a function and call this one, honestly, just basic wrangling. Of course, call these whatever you want to. These are your functions. You're going to modify them and make them even better than I show you on this video, hopefully. So, everything I'm doing is just a suggestion. Anyway, passing a data frame at a minimum. So I want to be able to look through and iterate through every column. However, it's possible that I might want to run something on just a single feature. So I'm just going to pass in a defaulted list of column names or feature names. I'm going to include something called a missing value threshold, which I'm going to default to 95%. So this is something I'll use when I'm checking for primary key columns. So even if not every single value is unique, maybe 95% of them are unique. Well, that's enough to say that column's still going to be pretty useless, and we'll just throw it out. So I'll have a parameter where we can set that. Also, I'm going to have one called unique threshold, which I'm going to default. I think I'm going to turn off my AI here just so it quits trying to automatically write things for me and we can talk about everything. Actually, I'll consent and then just hide the future. Yeah, okay, thank you. Close. take that back off. All right, besides the unique threshold, I like to print out messages along the way that lets me know what cleaning's happening when I'm first going through a consulting job or a data set, and I'm running it through these functions. I want to print out exactly what went on underneath. But then when I turn this into a pipeline where everything's automatically handled, I want to get rid of the messages later. So I'm going to add a parameter for that and default it to true. All right, begin with getting pandas in here because of encapsulation. As usual, we've always got to have that. I don't need any others, so I'm just going to get pandas. It's still giving me that AI. Let me go ahead and turn this off. I thought that would get rid of it for me, but I guess not. All right. So I want to iterate through every column one at a time and check for these three things above. So as usual, let's go through and iterate. I'm going to call it for feet and features. You might do for call and columns, whatever you want to call it. And also, since I'm going to let people specify a list of features they want to apply this to, what I want then is, by default, I want to check everything if they don't specify any features. But if they do specify a feature, I want to make this robust and error-proof. If they happen to specify a feature that doesn't exist, I don't want it to get an error. And so what I'm going to add here is an if feet in. I'm going to go ahead and look at the data frame they passed in and just grab the list of columns and just make sure that what they passed in here actually shows up. All right. So this is the path where I'll put all of my data cleaning. I'm going to go ahead and enter down a couple lines here and handle my false condition first. And if they have messages turned on, I'm going to go ahead and let them know that they gave me something that was not there. For example, the feature, let's see, that's the feature name. I'm going to go ahead and put quotes around it, so I'm going to need an escape character there. The feature, I'm going to put parentheses around that too. Oh, I guess I don't really need, if I've already got quotes around it. I'm probably overthinking this. Never mind, I don't need parentheses. All right, so the feature doesn't exist in the, maybe I'll put as spelled to give them a hint that they spelled it wrong in the data frame provided. All right, so let's just test things out. I'm going to simply add a continue message here so that it gets rid of my error. And at the end, I'm going to return their data frame back to them after it's modified. Remember, I'm going to come back and all my modification will happen right here. For now, I'm just testing this thing out. So stored that in memory. Let's go ahead and call this on the insurance data set. So I'm just going to call the function basic wrangling, pass in df insurance. Okay, so far all it's doing is taking the data frame that I pass in right here. It comes in as df. Everything else defaulted. It's skipping this entirely because I didn't pass in any list of features. So we could do something here. We could say, hey, we could either force them to always say features equals, and then they'd have to give a list like df insurance.columns. And then that passes it in. It did go through this time all of these, but all of the features existed, so it went through the loop, sorry. But this error message never showed up. My point is, we could set this up to work. Let me show. I think I didn't illustrate that well. Let me put in a list here and just spell something wrong. All right, so that's the only feature I'm applying it to. And I get this. The feature ASDF AS doesn't exist. It's spelled in the data frame provided. And then it simply returned the data frame back to us. So let's print something else right here, just so you can see that it is working. Print feature name instead of just continue. And let me not include features right there. So what we get is it skipped all of this. Notice how nothing printed. All it did was return the data frame, and no cleaning will happen if we don't specify the features we want cleaned. Well, what we could do is simply say, put in an error check for them and say if features, let's count it up here. If length features equals 0, then we could simply say features equals df dot, just take the data frame they pass in, and just go ahead and give them, or set this equal to the list of column names, so that we can be lazy later on and not have to actually enter in the features right here. So now if I skip this, let me go ahead and run this in memory. Run both of those cells. Now, even though I didn't specify the features I wanted to be included, it went ahead and this line just made sure that all features were then included. And yes, it did go through and printed each of them out one at a time. So that way, the only time I'd ever use this is if I wanted to apply it to a single one of them. And now you can see it only went through charges. Otherwise, if it's left blank, it'll just go through everything automatically. I think I like that. Let's do that so that we can be lazy later on when we call these. All right, so we've got our loop set up. Now all we need to do is put in the logic here to go ahead and complete each of these. So first of all, let's now check for empty columns. So as we go through each feature, let's just see if there's a lot of missing values. So in order to do that, I'm going to first calculate missing values. So I'm just going to set this equal to df feet for the individual column we're on. .isNA.sum. That's pretty easy. While we're at it, I want you to calculate two more things that we're going to use. The number of unique values. You can probably guess how we're going to use that in a bit. .nUnique. And then I'm going to go ahead and count the number of rows so I don't have to keep writing df shape later on. Okay, so with these, now I can add my path logic. So if missing, I'm going to have divided by rows is greater than or equal to the missing threshold provided. So in other words, if the total number of missing values divided by total number of rows is greater than, so that means if more than 95% of the column is missing, let's just get rid of the whole column. It's useless to us. So how do we get rid of the column? We're just going to add a df.drop columns equals feet in place equals true, and that'll be gone. Also, like I said earlier, I like to have messages when I'm first going through and running all of these functions so I know what's going on. So I'm going to add another if messages. I'm just going to print something like too much missing, and maybe we'll just tell them exactly how much is missing. So I'm going to add parentheses and give them the number, this out of, and then we'll add in the number of total rows. So that'll tell us how many rows are missing out of the total number of rows. And then let's also give them a percentage. That might be nice so they can see what percent that is. So I'm going to round a percentage and say missing divided by rows. I'll just go ahead and round it to 0 decimal places. And then I'll say for what column name? Feet. All right, so let's just make sure this one's working. I haven't used anything else yet. We're not going to get anything out of this one because there is no missing data. So let's run this on another one here. Basic Wrangling. Well, why don't we just run it on each of them while we're at it? df, what's our next one? NBA? Yep. df NBA. And then I'm just going to add 2 more of these. Let's add one in for Airbnb. Go ahead and run each of these. Oh, you know what? I just want to do the first 5. Save myself some space. Okay, insurance, no issues there. Basic Wrangling, not too much missing there. With NBA, same thing with insurance, no messages printed. And then let's check out, the last one was listings. Oh, not listings, what was it called? Airline. Okay, none of those had too much missing data. That's fine. We can up this, for example, to, I'm just going to do this temporarily here. Let's call, I know the NBA has some missing data for, I think, points. So I'm going to add missing threshold and set it to 0.001. So almost if there's anything missing, it's going to get rid of that. There we go. So here's our columns here. It's saying, hey, there was one value missing out of 467. That's so small, it's less than 1%. It rounds to 0% for this column. But it just gives me a message and lets me know, notice now that, well, actually, did I remove them? Drop columns in place, yep, and return. So those should be gone. Let's see, let's double check. Oh, yeah, because this is field goal percent, not field goal. A lot of these were in the middle there, but as you'll notice, none of these appear now in our data frame. If I were to print out all of those, they wouldn't be there either. Okay, perfect. Let's keep going. So now that we've got the missing issue taken care of, let's add another one, another path, and let's just simply test for the unique threshold. So again, my point with this is if, for example, if every single record is unique, I want to calculate that as a 1, meaning 100% are unique values. So we need the number of, it's going to be basically the number of unique values divided by the total number of rows. So elif unique divided by rows is greater than or equal to the unique threshold. Then same thing. Let's just copy this down. And we'll say too many unique values. And then instead of missing, unique out of that for that feature. Okay, that'll work just the same. And then lastly, let's just say, let's just check for, oh yes, that's right, columns with single values. One more elif here. Elif unique equals 1. So basically, if the total number of unique values that we get right here is only 1, then we're also going to get rid of that. That happens sometimes. So this one, maybe we can say only one value, I guess so. Only one value, and then we can tell them what the value is, actually. Why don't we do that? That'd be useful. Only one value, and then right here, to get one value, we need df feet, and we want .unique instead of nUnique, because that gives us a list of all the unique values. So if we call the unique method, and then just go to the first item in that list, oops, got an extra one of those. There we go. Then that'll tell us what that one is. I don't know if we have that in any of these data sets, but that comes up with stuff I pull out of a database every once in a while. All right, let's go ahead and run all these. Here, too many unique values for charges. Okay, this is a useful one, saying almost all of them are unique here. Well, wait a minute, that's a numeric feature. That's exactly what we want, is for we want to be able to keep numeric values with lots of different values. So what should we do about that? Basically, we only want this rule to apply when the data are not numeric. So if it's a number, that's fine. We want to keep it. Numbers, we like continuous numbers. That's not a problem. It's when we get like a primary key like, well, so in this case, it's a number, but that one is irrelevant to us. We don't want that one. Let's see. So basically when it's an integer, if everyone's unique, that's probably going to be some sort of primary key. If it's a float, like charges was, then it's not going to be a primary key, and it's something we're going to want to keep. If it is, for example, like player name or player additional, this version of the name, it's not numeric, and if everyone's unique, we definitely, or most of them are unique, we definitely want to get rid of those. So we've got some additional rules we've got to apply here. So if it is unique right here, and divided by rows, and that surpasses or is above our threshold, then let's add some extra checks here. So first of all, if it's an integer, this drop right here will only perform if it is not a float. So if it's an integer or if it's an object. So what I want is an extra check for the data type. So let's print out right here the df feat and add .dtype right there. So just so we can see what we're getting for each one of these. Oh, that one didn't. Oh, it's applying this. There's sometimes some memory issues with Python. I've learned, even though that was supposed to be done on a copy, sometimes it happens on the original. So I'm going to actually just re-pull it in right here. Rerun that line where I bring in the insurance data. All right, there we go. So here's our charges once again. That's a float 64. So I only want this to run on int 64 and objects. So how about we say if df.dtype in, and we make a list of these. Int 64 object, then we want to go ahead and drop it. Otherwise, we won't worry about it. All right, let's see if that one works. Perfect. Okay, leaves charges for us. Let's see if it works on another one. Let's take this off. We don't actually want the missing threshold to be something like that. We might say, 0.5 though, for example. And in that case, none of the data are actually, I better bring NBA salaries down here, just so that make sure that we don't have that issue again. There we go. So good. It worked for unnamed 0 because that was an int, and that's what I wanted. So since it was an int, it went ahead and said too many unique values for unnamed 1 and dropped it along with player name and player additional. Notice something like team. This is the team gets repeated many times because there's lots of players on a team. This is useful data because it can say something about the market cap or the amount of money that teams have available to spend. So that's a useful feature. But those other ones, again, non-standard values, they're not going to do anything to help us predict or explain things above and beyond the data that we already have. Okay, let's try it on Airbnb. See what we get here. Okay, good. Gets rid of ID, name, and neighborhood group. Okay, it still keeps neighborhood. Neighborhood group was a different one. Thank goodness, because neighborhood's useful in this particular data set if we're wanting to predict, for example, how many reviews it's had or the average review. There it is. That's usually what we predict on this Airbnb data. Try to predict how much people like each property based on all the rest. So neighborhood certainly matters. Host name, at first you think, well, wait a minute, that's going to be unique and host ID. However, the same hosts own a whole bunch of Airbnb properties, and there could be information about that host that applies to all of those properties that's useful. So glad I didn't get rid of that. But we could always, if we see something that we feel like it should have gotten rid of, all we have to do is when we call this, we can modify some of these parameters, like the unique threshold. You know, what it takes if we were to up that to something, or lower that to something like 50%. I wonder if that would get rid of some of them. Yep, sure enough, gets rid of host ID at that point. Host name is probably repeated, though, over multiple host IDs, and that's why I didn't get rid of that one. But we can modify these parameters to have it get rid of more and more as we test it out. But again, it's nice just to have one single function, and now it handles 3 very common jobs for us with data wrangling. All right, let's stop this video right here. Oh, wait, did I get all of them? Yeah, I did. Okay, perfect. Let's stop this video right here, and then we're going to move on with date and time management in the next one.